Imagine a microscopic device smaller than a grain of sand, so tiny that it can barely be seen by the naked eye. This device is not just a marvel of miniaturization, but a gateway to a new frontier in science and medicine. Capable of eavesdropping on the electrical symphony of your thoughts, it listens to the intricate dance of neurons firing in your brain. This is not science fiction, it's the cutting edge of neuroscience. This is neural dust, a revolutionary technology poised to redefine our understanding of the brain and its boundless potential. Imagine a world where we can monitor brain activity in real time with unprecedented precision. These minuscule sensors, developed by researchers at the University of California, Berkeley, represent a giant leap forward in neuroscience. They are designed to be implanted in the brain, where they can transmit data wirelessly, providing a continuous stream of information. They hold the key to unlocking the mysteries of the brain, paving the way for groundbreaking medical treatments and mind-boggling technological advancements. From treating neurological disorders to enhancing cognitive functions, the possibilities are endless. But with such power comes profound ethical questions about privacy, autonomy, and the very essence of what it means to be human. As we stand on the brink of this new era, we must carefully consider the implications of merging technology with our most intimate thoughts. The future of neural dust is not just about scientific achievement, but about how we choose to integrate this technology into our lives. Will it be a tool for unprecedented human advancement or a step too far into the realm of the unknown? Only time will tell. Neural dust emerged from the visionary minds of engineers and neuroscientists at UC Berkeley in the early 20s. Their goal was ambitious: to create a wireless, battery-free neural interface that could record brain activity with unprecedented detail and longevity. The challenge lay in miniaturizing the technology while maintaining its functionality. Traditional brain-computer interfaces relied on bulky electrodes and wires, limiting their practicality and long-term viability. Neural dust, however, promised a paradigm shift. The secret to neural dust's remarkable capabilities lies in piezoelectricity, a unique property of certain materials that allows them to convert mechanical energy into electrical energy and vice versa. This phenomenon is not just a scientific curiosity, it has practical applications that are transforming the way we interact with technology. Piezoelectric materials are found in everyday items like quartz watches and electric lighters, but their potential goes far beyond these simple uses. In the realm of medical technology, piezoelectricity is opening new frontiers, enabling innovations that were once the stuff of science fiction. These tiny sensors, each a marvel of microengineering, contain piezoelectric crystals that vibrate in response to ultrasonic waves emitted by an external device. Imagine a world where these sensors can be implanted in the human body to monitor vital signs or even detect diseases at an early stage. The piezoelectric crystals within these sensors are incredibly sensitive, capable of picking up the slightest mechanical changes and converting them into electrical signals. This sensitivity is what makes them so effective in medical applications, where precision is paramount. These vibrations generate an electrical current that powers the sensor and enables it to detect the faint electrical signals produced by nearby neurons. This is particularly useful in neural interfaces, where the goal is to create a seamless connection between the human brain and external devices. By harnessing the power of piezoelectricity, these sensors can operate without the need for bulky batteries, making them ideal for long-term implantation. The generated electrical current is not just a power source, it also serves as a means of communication between the sensor and the neurons, allowing for real-time monitoring and interaction. The sensor then encodes this neural data onto the reflected ultrasonic waves, which are picked up by the external device for processing and analysis. This method of data transmission is both efficient and non-invasive, ensuring that the patient experiences minimal discomfort. The external device, equipped with advanced algorithms, can decode the data to provide valuable insights into neural activity. This technology holds promise for a range of applications, from treating neurological disorders to enhancing cognitive functions. The power of piezoelectricity is truly revolutionizing the field of medical technology, paving the way for a future where the boundaries between biology and technology are increasingly blurred. Imagine a neuroscientist wanting to study the neural activity in a specific region of the brain responsible for motor control. They would implant a few neural dust sensors, each smaller than a grain of rice, into the targeted area. These sensors would then silently listen to the electrical whispers of neurons as they fire, transmitting this data wirelessly to a receiver outside the skull. This would provide researchers with an unprecedented glimpse into the complex neural orchestra that governs movement, potentially leading to breakthroughs in treating conditions like Parkinson's disease and paralysis. The potential applications of neural dust extend far beyond the realm of medical research. Just imagine a world where people with prosthetic limbs can control them with the power of thought, their movements fluid and intuitive. Picture individuals with severe paralysis regaining their independence, able to interact with their environment through thought-controlled devices. And think about a world where communication transcends the spoken word, where thoughts and emotions are shared directly through a neural network. The prosthetic renaissance. One of the most promising applications of neural dust lies in the field of prosthetics. By implanting these sensors into the remaining nerves in an amputee's limb, scientists could create a direct link between the brain and the prosthetic. This would allow for intuitive, fine motor control, enabling users to regain lost dexterity and experience the world through their artificial limbs. Imagine feeling the warmth of a loved one's touch or the subtle texture of a fabric, all through a prosthetic hand controlled by thought alone. Shadows in the machine. However, the immense potential of neural dust is not without its ethical shadows. The ability to monitor and potentially manipulate brain activity raises serious concerns about privacy and autonomy. Who will have access to this data? Could it be used for malicious purposes such as thought control or surveillance? These are questions that society must grapple with as this technology continues to evolve. The future of thought. The future of neural dust is a tapestry woven with both promise and uncertainty. As the technology matures and becomes more sophisticated, it could lead to a paradigm shift in our understanding of the brain and its boundless capabilities. Imagine a world where learning new skills is as simple as downloading information directly into your brain, or where communication transcends language, allowing for instantaneous sharing of thoughts and emotions. A network of minds. The most profound implication of neural dust lies in its potential to connect human minds directly to each other and to the internet. This technology, still in its nascent stages, promises to revolutionize the way we communicate and interact. Imagine being able to share your thoughts and emotions instantly with someone across the globe without the need for words or devices. This could lead to unprecedented levels of understanding and empathy among people. Imagine a global network of interconnected consciousnesses, sharing thoughts, ideas, and experiences in real time. This network could transcend language barriers, cultural differences, and even physical disabilities, creating a more inclusive and connected world. The possibilities are endless, from collaborative problem-solving on a global scale to the creation of new forms of art and entertainment that we can't even begin to imagine today. While such a scenario might seem like science fiction today, the rapid pace of technological advancement suggests that it could become a reality sooner than we think. Innovations in artificial intelligence, machine learning and biotechnology are accelerating at an unprecedented rate, bringing us closer to this interconnected future. However, with great power comes great responsibility, and we must tread carefully as we navigate this uncharted territory. The ethical and societal implications of such a profound shift in human connectivity are staggering, demanding careful consideration and open dialogue. Issues of privacy, security and consent become paramount when our very thoughts could be shared and accessed by others. We must also consider the potential for misuse and abuse of this technology and the impact it could have on our mental health and well-being. The future of neural dust is not merely a technological question, but a philosophical one, challenging us to redefine the very essence of what it means to be human in an age of interconnected minds. As we stand on the brink of this new era, we must ask ourselves, what do we gain and what do we lose when our minds become part of a larger network? The answers to these questions will shape the future of humanity in ways we are only beginning to understand.